Okay, so this is a quick Sig Figs guide. And let's first start with an overall example that will hopefully illustrate why this is important. Because I think it gets lost a lot with people is why do Sig Figs actually matter, and they seem kind of arbitrary. So let's take an example here. On the left, we have this really precise scale. Say it's measuring like a bouncy ball or something, and it's got that really small mass. And then say we're measuring a dude over here. He's 185 pounds. So what would the sum be of the ball and the person? You'd probably be tempted to say, 185.0006 pounds. And if you said that, you would be wrong. Why would you be wrong? Because if we look at this scale here on the right, it only has 4 significant figures. So let's write this out. 185.0. All the digits to the right of this 0 right here, whatever these might be, could be any number. When you take this answer, you're assuming them all to be 0, but they could be any numbers you want. It could be 1, 9, 2, 3, 4, blah, 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 blah. They could be literally any number you want. So when we try to add this 6 right here into this number, and you get the 185.006, you're wrong because you're assuming all of these digits are all 0. When in reality, you're just adding that 6 into the noise that our big scale is calculating. So here, the correct answer would just be 185.0. The mass of that ball is not accurately measured in sum with the right scale. So now let's do a more general approach. Let's see how do we identify how many sig figures a number has. So what is a significant figure? First, any non-zero number in a number is going to count as a sig fig. So 3 is a significant figure, 4 is, also 2 is. So this one has 3. 342 has 3 significant figures. Also, any 0 that is to the left of a decimal point is also a significant figure. So 6 is a significant figure because it's non-zero, and these zeros are both to the left of a decimal point, so they're also significant figures. So 600 decimal point has 3 significant figures. And it looks odd writing it that way, having the decimal point, because usually you just write it as 600, not 600 decimal point. The decimal point is there because it's signifying that these zeros are not just being rounded to, and they were actually measured zeros. So that's why we're counting there as 3 significant figures. Also, any zeros that come to the right of a decimal point that have a non-zero number to the left of the decimal point are also significant. So it sounds kind of confusing. So we know that 6 obviously is significant because it's non-zero. These zeros are significant because they're to the left of a decimal and also in between another significant figure. But these zeros are also significant because this number on the left over here is non-zero. So the more logical interpretation here is that these zeros, they were once again, these are measured zeros, that whatever machine we use to measure them, those zeros were actually measured and they're not just being rounded up. If they were just rounded up, we would write it like this 600. But anyways, so we have 5 here, so this one's 5 significant figures. And then we come down to 600. 600 has no decimal point, so it only has the 6, so that's 1 significant figure. So here, where we don't have the decimal point, these zeros are just assumed to be essentially rounded, and they're not significant, and therefore we only have the 1 significant figure of the 600. Same deal down here with the 72,000. We have a 7 and a 2, and none of the other zeros are significant, so we have 2 significant figures. And then same thing when you go to the right of a decimal point, none of these zeros are significant figures. We only have the 6. So that's 1 sig fig. Now, similar to what we saw up above on this example, we have the 7, we have the 2, we have the 6, and these zeros are also going to be significant because they're sandwiched between. We have a non-zero number on the left. So what is that? That's 7 sig figs. Okay, so that was a quick outline how to count sig figs. Now let's get into some operations. For addition and subtraction, they both work exactly the same way. What you're going to want to do is you're going to want to add your numbers and then round to the least precise significant figure of the numbers you're adding. So that sounds kind of confusing. Let me just show you what I mean. It'll probably make more sense after I just show you. So let's first identify the significant figures we're going to be comparing. And it's the rightmost sig fig on each number. So on 185.0, our rightmost sig fig is this 0. It is significant because there's a decimal point. And this 6 right here. So those are the two rightmost significant figures in each number. And we're going to round our final answer to which one of these sig figs is less precise. So first, what is our answer? Our answer would be 185.0006. And we're going to round this number to the least precise decimal position. So let's see, which one is 0 or 6 less precise? This 0 is in the 10th position. It's the first number after the decimal point, and this 6 is in the 4th position after the decimal point, which means it's in the 10,000th position. This 0 is the less precise number. So therefore, we're going to round up to the 10th position. We're going to round up to this decimal point right there. And if we round this, we're going to get, that was an arrow, we're going to get 105.0. So then our answer there is 185.0. So let's see here. For 132 and 240, this has 3 sig figs. This has 2. Not that it's important for addition or subtraction. The rightmost sig fig on each one. We have the 2 there, and then we have the 4 here. And our unrounded answer is going to be 372. And which one of the 2 and the 4, which one is the least precise significant figure? It's this 4. It's in the greatest position. It's because it's in the 10 spot as opposed to the 1 spot of the 2. So we're going to round to the nearest 10, which is going to be 370. Okay. So there we go. There's a quick overview of addition and subtraction. Let's do multiplication and division, which is a little more straightforward. For multiplication and division, you're going to count the sig figs of each number you're adding or multiplying, and then just round to the lowest one. So, let me get this open. Okay. How many sig figs does 185.0 has? Significant, 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 significant. It has 4. And significant, significant. This one is 2. So I'm going to take my final answer. So when you put this in your calculator, you get that, 6.105. We're going to round to the lowest number of significant figures. 2 is lower than 4. I'm going to round to 2 sig figs. So I'm going to get 6.1. Pretty simple. Okay, let's do 17 over 161. This has 2 sig figs. This has 3. So therefore, we're going to round our final answer to 2 sig figs. And we would get 0.10559, blah, 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 blah. And we are going to round this to 0.11.